Hey class, it's Professor Rourke. I wanted to make a video about the optimization problems. I thought I had some already recorded, but apparently not, or I'm not sure really where they are. So that's okay. Here we are. So the problem that I wanted to start with was the problem from WebAssign that I had a question on. This was number 4 in the WebAssign homework from the 4.7 optimization homework. Okay, so I'm going to read the problem and then I'm going to switch over to using the whiteboard to kind of write things out. So for this problem, it says the rate in milligrams of carbon per meters cube per height, I think, at which a photosynthesis takes place for a species of phytoplankton is modeled by the function P equals 80I all over I squared plus I plus 9. Also, side note, sorry, my kids are outside playing and they're screaming, so I have my headphones on, and I'm sorry if you hear it, they're fine. They're not hurt. They're just intensely playing soccer. Okay, so where I is the light intensity measured in thousands of foot candles, for what light intensity is P at a maximum? Okay, so no matter what kind of chaos they throw at us in these problems, okay, there's always like that common thread of the steps that the textbook recommends and we follow and in our notes. So first things first, I'm going to go ahead and again switch over to just a whiteboard. That way I can just sort of write everything out. Anything else? Okay, so P equals 90I, right? And then this is all divided by I squared plus I plus 9. Okay, so again, I know it's sort of, I don't know much about the rate of photosynthesis um, or the light intensity. But it doesn't really matter right now because all that says again is for what light intensity. So like for what I is P at a maximum. So really it's more straightforward, I feel like, than you might think for some of the problems. We might be required to sketch a diagram, especially if it's like a box or some sort of shape, and we're trying to maximize or minimize like the surface area or the perimeter or the area, things like that. Definitely would need some sort of diagram to start out with. But for this particular problem, Eh, I don't think we really need that. P is what they tell us is this rate of photosynthesis, and I is the light intensity. They want us to find I so that P is at a maximum. So we're kind of like already sort of like in step 4 of the optimization problems. Diagram doesn't really make sense. We do have an equation for the the rate of photosynthesis, and that is what they're asking us to actually maximize because it says again, for what light intensity is the P at a maximum. So they're telling us to maximize this. And so again, a lot of times they'll maybe give us other constraints that we would maybe need to use to try to get this equation all in terms of one variable, but we're actually already there. We already have the equation, didn't have to come up with it ourselves, and we didn't have to turn it all over to one variable. So I feel like we're winning so far, so good, but I feel like the next part might be where it gets a little trickier. Okay, so once whatever the problem is that we're given, once we figure out what they're asking us to maximize or minimize, right? And then we like take a look at the other extra information that they sometimes call the constraints, right? And we use the constraints a lot of times again to rewrite whatever we're trying to maximize or minimize in terms of just one variable. We've already done that. Okay, so once we do that, which again, we're already here, we're going to go ahead and take the derivative, and then we use that to either set equal to 0 most times. We do also want to check the any domain restrictions on the derivative because technically critical numbers happen at 2 places, right? Where the derivative equals 0, but we also need to check where the derivative doesn't exist. So because this is already a rational expression, I'm thinking that could maybe come into play. But let's see. I don't know. All right, so let's go ahead and start out by finding the derivative of P with respect to I. So this requires something we haven't seen for a couple weeks, which is the quotient rule. So that's always exciting. Okay, so it's like low D high, right? Minus high I don't really like writing capital I as a variable. It's kind of, but that's okay. D low, just unusual, I feel like, for this class, but we can do it. Okay. And then it's all divided by low or low squared. Okay. So that's something. That's nice. Okay. And then, in theory, in parts of this class, if it just said find the derivative, you could just leave it here and be done. But especially for this chapter, this is where we're going to want to make sure that we simplify when possible. It definitely makes it much easier to try to solve these problems. So one thing I do notice right off the bat in term for this problem, and it's not probably going to be make or break it in terms of if you don't notice this, but I do notice that there's a 90 two places in my numerator, and that happens a lot in quotient rule, right? Just because of like the nature of quotient rule, how we have like low d high minus high d low. Chances are that there's going to be a common denominator, or a common factor often. So I'm just going to go ahead and take that out now. I don't know if it'll be helpful, maybe not, but I just sort of look for that first. I don't think there's anything else I could take out because on my left-hand side, I have I squared plus I plus 9. And then on the right-hand side, I have I times 2I plus, that's supposed to say plus 1, by the way. I'm sorry. I started talking about how I don't like writing I's and then I accidentally wrote an extra one in there. So that's, I don't know. Here we go. Okay, so we actually have I times 2I plus 1. So I'm going to go ahead and rewrite this. I'm going to pull out the 90. Again, these are sort of those simplifying steps that we practiced before the last test, but it can be helpful here as well. So I'm going to go ahead and distribute in the negative I into 2I plus 1 to make that negative 2I squared minus I. Okay, so I hope that kind of makes sense what I did there, just to kind of pull out the 90, and then I got this whole can of worms in the bottom, I squared plus I plus 9. I feel like if I was a student, I'd be tempted just to switch over to X's, but whatever, I'll just keep suffering through this because, again, I guess it shouldn't be that big of a deal. Okay, so then from here, we're going to go ahead and combine like terms, right? This is just a lot of simplifying, I feel like, in this particular problem. So we could do, let's see here, I squared minus 2I squared, I'll say is negative I squared, right? So that's something. And then I have I and negative I. So those I's will actually go away. And then I'll be left with plus 9. And then again, we got this whole can of worms in the bottom. I'm sorry about the dogs. We got dogs. We got kids. We got the whole circus here today for you. Okay, so next. Okay, so it's a little funky in the numerator. It's negative I squared plus 9. So we have a couple options here. One is to go ahead and try to set the numerator and denominator equal to 0. You could definitely do that. It's sort of icky. Like I would maybe factor out a -1 to rewrite this as I squared minus 9. But either way, it's the same. It's the same thing. Okay, so I won't do that in case you didn't recognize that. But what we would want to do first is like, okay, where does the derivative equal 0? That's when the numerator equals 0, right? And then I also want to check to see where the derivative does not exist. Okay, and so that's essentially where the denominator is going to equal 0, right? So let's talk about this first. Okay, so on the negative I squared plus 9, we could solve for I, right? We can subtract 9, technically like divide by -1. I don't know. Either way, we would get I squared equals 9, so I equals positive and -3. Okay, and then we could try to solve I squared plus I plus 9. Ugh, you know, it's not factorable. Um, Technically, I guess you could look to see if you would solve it using the quadratic formula, but if you're doing that, like that's essentially also would be a domain restriction on the original. So I don't think it's going to be a thing, because if it's where the derivative, if that's where that doesn't exist, let's say I could find it using the quadratic formula and it's kind of probably like a yucky number, the problem still would be that, it would also be a domain restriction on the original, so it wouldn't make any sense for the problem. Okay, so nada, I'm not going to do that. Um, and then, again, I don't know a lot about photosynthesis and light intensity, but I'm pretty sure light intensity cannot be negative. So really, that just kind of leaves us with the only real option. If we have I is positive -3, I think I equals 3 is the only real candidate, right? And then a lot of times, once we kind of get that critical number, sometimes we're done. Sometimes we might need to like make sure we read the question again and see what they're actually asking you for. So this one specifically just says for what light intensity is P at a maximum. And so they just want us to put 3 for this particular problem. Would want to kind of check to see um, is this a maximum? In theory, could it be a minimum? Like, how would we determine that? Okay, so there's two ways, right? And depends on which one's the quickest. And for this one, eh, I don't know. None of them are great. I would say you could either do the first derivative test, right, where you pick some numbers, like essentially on the number line, almost like the increasing decreasing test, and figure out where the derivative is positive and where it's negative. And so, like for instance, if you again, this is like with the first derivative test, which is really like the same thing as increasing decreasing test. So if for this one, if you wanted to pick, I don't know, something like 1 and plug it in to the first derivative, you can try to save some time by doing a couple little quick steps. I think we would see that it looks like it is increasing. Yeah, it would be positive because it would be essentially like positive divided by a positive. Um, if I plugged in something like 1, and if I plugged something bigger than 3, like 4, I think that would make the numerator negative, and the bottom would always stay positive. And so it would be like positive and then negative. So therefore, I equals 3 would be like a where there's a maximum, just sort of like a double check. Typically, if there's only one answer, like 99% of the time, it's going to be the maximum or minimum that they're looking for. But every now and then they might be rude, and not not give you the maximum or minimum that we're looking for. So let me go ahead and go back to that problem that we were looking at. Okay, so yeah, again, this one we would just say 3. Okay, that would be the light intensity 3. So I hope that was somewhat helpful. Again, just sort of looking through these problems. Number 5 is a box, and that's a very like common question where they maybe give you either the surface area and tell you to maximize or minimize the volume, or in this case, it's opposite. They give you what the volume is, and then they're asking you to find essentially minimize the amount of material. So that one's a good one. Same idea, another box. This time they give you the amount of material and you're asked to maximize the volume, right? This question is similar to one of the examples. From the text where it says find the point on this line that is closest to the origin. So they're talking about if it's closest, they want you to minimize the distance, right? And then for the point, like the origin, we'd use 0, 0. And for one of the y's, we'd put 5x plus 2, right? So after a while, they do start all kind of sounding similar. I know at first they don't. This next one, we got a poster, and they give you these margins. Then it says if the area of the printed material in the poster is this certain amount, find the dimensions of the poster with the smallest area. Why you'd want to find the smallest area, I don't really know, but that's okay. So a lot of different kinds of examples that I know again all can sort of seem all over the place. I do like some of them have like the read it and watch it on here, which are sort of nice. So I know the watch its can be helpful, especially for this number 6 here, talking about the box. And they're asking you to maximize the volume. Number 7, same thing. You can watch it regarding the distance, which can be helpful. You can watch it on the poster. So those can just be helpful to sort of get you in the right direction. But I do recommend if you do try to watch it, maybe if you can, challenge yourself to try another one. They can refresh it with a similar question and see if you really can have the concept that way. Okay, I hope this was helpful again. This was again 4-7, question 4 from the WebAssign, but please keep me posted with whatever I can help with. Okay, thank you. Have a good one.